Okay, so in this section, I'm going to go through the history of Vim and Emacs, and by the end of it, hopefully you can appreciate why they are the way that they are. Okay, so first of all, Vim. Now, in order to look at the history of Vim, I am now going to go to Wikipedia and go straight to the Vim article. And from here, I'm going to look at the history and just go down its predecessors list so that by the end of it, we can get to the earliest sort of baseline editor. Cool, so I'm going to go back in time. Now, Vim, or Vi Improved, is a free and open source screen-based text editor program. It is an improved clone of Bill Joy's VI. Vim's author, Bram Moolenaar, derived Vim from a port of the Stevie editor for Amiga, and released a version to the public in 1991. Vim is designed for use both from a command line interface and a standalone application in a graphical user interface. Since its release for the Amiga, cross-platform development has made it available on many other systems. In 2018, it was voted the most popular editor amongst Linux journal readers. In 2015, the Stack Overflow Developer Survey found it to be the third most popular text editor, and in 2019, the fifth most popular development environment. So, still very much relevant today, even though it was made like 30-ish, yeah, a bit over 30 years ago, which is pretty impressive. So now for the history. Vim's forerunner, Stevie, which is the ST editor for VI enthusiasts, was created by Tim Thompson for the Atari ST, which is a computer model, I think. Yeah. Yeah, a line of personal computers, in 1987, and further developed by Tony Andrews and G.R. Fred Walter. It was one of the first It was one of the first popularized clones of VI and did not use VI's source code. The source code for VI used the ed text editor developed under AT&T, and therefore VI could only be used by those with an AT&T source license. Basing Vim on the source code for Stevie meant the program could be distributed without requiring the AT&T source license. Good. So even though Vim is VI improved and is based upon the behavior of VI, it is ultimately based, in terms of its source code, on Stevie, which is a clone of VI because VI had the AT&T license tied to it. So that's a very key thing. But let's go back to, let's go to Stevie first. I know in the Stevie article there isn't much here. I had a look at it before. It only just reiterates what we said before. It's a discontinued clone of Bill Joy's VI text editor. That's all good. So Stevie was written by Tim Thompson for the Atari ST. We know that as well, and we basically know this, so that's fine. So there isn't much here, but it does point us back to VI, so let's go there. To look at this, I'm going to look at the history section alone, and it's quite chunky, but very, very illuminating. So, VI was derived from a sequence of Unix command line editors, starting with ed, which was a line editor. Oh, that keeps on doing that. Let's not do that. Here we go. Which was a line editor designed to work well on teleprinters rather than display terminals. Now, you might be wondering, what is a line editor and what is a teleprinter? I thought it would be easier to show you than tell you or read to you. And so I'm going to bring up a video here. Now, how's the volume? Okay, that should be all right, 70%. In case the volume here is a bit loud, do turn down the volume if you have it fairly loud now on your device. Cool. Hopefully you've done that. You can pause the video, of course, to do that. So that should be good. So I'm going to play the last, well, near the end, near the third to last section. And what this person's going to show is him using a teletype terminal, which you can see here, in order to edit some text. What he's done is he's got this teletype printer, hooked it up to a Linux machine, and therefore all the input and output is handled by this teletype on printed paper, as you will see. So it's pretty cool. And also this teletype printer is from the 1930s, so it's quite an old thing. I mean, the 1960s and 70s, I believe, would have had teletype printers that had a lot more functions than this. But this really does look like a typewriter with wires.
So I should have a computer at the other end of this old mechanical contraption. So, let's do an alias.
This is just a,
because I know
this is just a extra command he has to do because of color, so it's nothing important.
This distribution does color by default,
yeah.
which is will give me all the extra characters I don't want.
This is the important bit.
LS. Let's see what we have in this directory.
So for those of you who don't know, ls is the terminal command on pretty much all Unix operating systems to print the contents of the current directory. That's what he's doing now. But on a terminal emulator that you would have on your computer, it's just printing it in a flash on the screen. Here, it's printing it, capital P. That's cool.
Okay.
That is cool. That is just so cool. I mean, imagine if your computer was this. The neighbors would go absolutely berserk every single night because of the noise. But, I mean, yeah, it's just cool. I find this just super cool. This is programming, man. This is programming. Imagine typing and you're physically making something happen. You don't do that now. You don't get that experience now. Because when you type it, just this on a screen, you don't hear anything. It's very, what's the word? Sensorily deprived, I guess, is that the word? Yeah, there's not a lot going on, basically. So to have this feels like it would be very, very fun.
So what can you do? Well, probably not very much, because you can't do any programming, because you don't have even there's no plus sign, there's no equal sign, there's no backlash, so you're really limited in what character you can input into this thing.
Yeah, so there, what he means is this specific 1930 teletype is not able to take in inputs like a adding, addition sign, equal sign, backslash. So he can't program, on this particular machine. But there are several other teletype printers that would have been able to handle those characters, and you would have easily been able to program on them. And indeed, that's how we did program on them. So I just want to clear that up in case it leads to any misconceptions.
But I could do a little bit of single line editing. Okay. Let's try it.
Yeah, so this is where he does that single line editing using ed. He's going to use ed here, and this is a line mode editor. Cool.
Let's do ed. Ed. Okay, single line editor. This no happen. There you go. Then I go second line. So ed being the original editor for teletypes, one line at a time, and to get out of it, it's fixed dot. I have to go back to letters or I'll forget. Alright, and now I want to change the second line, so I would...
Okay, just a note here, I'm gonna go through more about ed later on, because I've got it installed on my computer, so I'll show you, but he's just using it on the Teletype printer, and I think that's really what I want to show you here is why you would want to use something like Ed here on a Teletype printer. It's because you cannot possibly edit text visually or in a sort of what you see is what you get kind of interactive visual way. You can't do it because the text is already printed on the page. You can't unprint text. So that's why you needed something like Ed.
Would go to line 2, fix 2 letters at the teletype. Now I want to change it. I do C. Then I do cap, test, V.
Okay, so I'm going to end it here, but he edits some text with Ed, then prints it up to standard output. You can see it. This is hard work at the model 15, but it works, right? Cool. So that's a Teletype printer. And here we go, I think. This is him printing some ASCII art. I think that's pretty cool to see. I think he zooms out so you can see the whole printer. But the main thing about using Ed, I'll go into that a bit later, is because you had to use something like Ed on a Teletype printer. You couldn't visually edit. Okay, but anyway, I mean, this should be pretty cool. Let's have a look what this is.
What people used to do a lot is print ASCII art. They are very nice. Takes forever to print though. There, not that.
Yeah, there we go.
There, session.
That's pretty cool. So it's literally like a typewriter. That's just pretty cool.
There, not that it's useful or anything, but it can be done. In 1930, Bodo Teletype commenters, I think, have done it.
Anyway, yeah, that's pretty cool. I tip my hat to this guy for rebuilding a 1930 Teletype printer and hooking it up to a Linux machine. So yeah, none of that sounds easy. But anyway, now you have a bit of background, hopefully, on what a Teletype printer looks like. Now I'm going to show you Ed and show you a bit of its functionality, just because it's pretty cool to try. But here it is. I've gone into it and it's just incredibly ambiguous. This is the interface. It's just nothing. I find that pretty funny. Anyway, I am in now a file buffer. I'm currently editing a new file. I haven't written it to disk yet, but I'm in the file, but there's no text in the file. So to do that, I want to, well, first of all, actually, you know what? If I type P, I can print the current contents of the file. It throws me an error because there is nothing in the file. There's nothing to print. That's why I get a question mark. So I want to go into append mode and add some text. So line 1, line 2, oh, line, oh boy, can't type, line 3, and line 4. Good. So I click dot to go back into command mode. That's it. I've made a file. I've typed text in the file. If I click P, that prints the current line that I'm on. If I type comma P, that prints the whole file. Because if I wanted to print a range, 1, 2, P, I'd print the first 2 lines. But as a shorthand, just comma P prints the whole thing, right? So you don't have to put the first and last line because you might not know what the last line is. So you can just put comma and it'll print it. I think 1 comma must be the same. No, never mind. It just prints the first line. Because you can also print the nth line by putting a number at the beginning. Now, if I type P, that tells me the line I'm currently on. I'm on line 2. The reason why is because there is an imaginary cursor in the file at line 2, which is where I'm at, right? If I jump to line 1 by typing 1, it moves that imaginary cursor to line 1, but also prints the line that I'm on to show me where I'm at. So I'm at line 1. Good. If I want to jump back again to line 4, which I can do, I'm there, that's good. You get the idea? The whole system is you jump to lines, you can edit lines, that sort of thing. You can also change lines that you've made by using the change command, which I haven't mentioned. So I'm at line 4 now. If I want to jump to line 3 and then change that line, I can say this is a changed line 3. There we go. And then go dot to go back, and then I can print the whole file again, and you can see line 3 is changed. Cool. Now, where am I? I'm at line 4, not line 3, because when you print the file, you change the cursor position, because you're moving the cursor to print the current line. And so by printing the whole file, you're starting at line 1, printing it, going to line 2, printing it, going to line 3, printing it, going to line 4, printing it. That happens under the hood. So now that's why I'm at line 4 now. But yeah, that's it. I'm at line 4. I can also go insert mode. That adds something before line 4. So this is the new line 4. There we go. And I can go back and then I can print the whole thing again. There we go. So yeah, that's ed. Now, I can also write this to a file, thing.txt, that's 69 bytes, and then I can hit Q to quit. Yeah, whoops, I press hashtag there. And if I type ls, you should see thing.txt, and if I do cat, boy, I cannot type today, thing.txt, there we go, you can see it there. It's just a text file, and it's edited in a really wacky way that's not intuitive to modern text editing people. So there we go. That is Ed. And hopefully you can understand it a bit more now, having seen me go through it a bit. But now you can redigest, or is there a word? Redigest? I mean, yeah, you can read this again with a bit more background, having now seen a teletype printer, or teleprinter, and having seen what a line editor is about. So, I will read it again. VI was derived from a sequence of Unix command line editors, starting with ED, which was a line editor designed to work well on teleprinters rather than display terminals. Within AT&T Corporation, where ED originated, people seemed to be happy with an editor as basic and unfriendly as ED. I hope that's clear. It is certainly basic and it is certainly unfriendly. But George Coulouris recalls, for many years they had no suitable terminals. They carried on with TTYs and other printing terminals for a long time. And when they did buy screens for everyone, they got Tektronix 4014s. These were large storage tube displays. You can't run a screen editor on a storage tube display as the picture can't be updated. Excuse me. Thus, it had to fall to someone else to pioneer screen editing for Unix. And that was us initially, and we continued to do so for many years. Coulouris considered the cryptic commands of ED to be only suitable for immortals, and thus, in February 1976, he enhanced ED using Ken Thompson's ED source as a starting point to make M the editor for mortals, while acting as a lecturer at Queen Mary College. Sorry for the gap there, that's the end of the sentence. The M editor was designed for display terminals and was a single line at a time visual editor. So by this, I think what they mean is you could call a line and interactively edit it as you would in a normal line editor. So a visual editor is kind of like a modern, sorry, not a normal line editor, a normal modern text editor. So a visual editor is like we have today, I believe, with modern text editors. And so calling a single line at a time and visually editing it means you would call a line and it would pop up. So I would get something like, hello, this is line 1 or 12 as I've inputted by accident. So we've got this line, then I can edit it interactively, visually, go back here, put that there, do that. And then I can, say it's all good, then it'll get put back in, right, the file, and then I would ideally see that line in the file. So I think that's what they mean here, a single line at a time visual editor. It was one of the first programs on Unix to make heavy use of raw terminal input mode, in which the running program, rather than the terminal device driver, handled all keystrokes. When Coulouris visited UC Berkeley in the summer of 1976, he brought a deck tape containing M and showed the editor to various people. Some people considered this new kind of editor to be a potential resource hog. Can you imagine? But others, including Bill Joy, were impressed, and that name should ring a bell. Inspired by M, And by their own tweaks to Ed, Bill Joy and Chuck Haley, both graduate students at UC Berkeley, took code from M to make N, and then extended it to create EX. After Haley's departure, Bruce Englar encouraged Joy to redesign the editor, which he did June through October 1977, adding a full-screen visual mode to X, which came to be Vi. There we have it. V and X share their code. VI is the X binary launching with the capability to render the text being edited onto a computer terminal. It is X's visual mode. So what that means is when you typed VI in the terminal, you were calling X technically already in the visual mode. So really VI initially was just a mode of EX, X. Now, if you're used to Vim or have used Vim before, you'll know that the visual mode of Vim is very different to what's being described here. Visual mode in Vim is basically like the text selection mode in Vim. But the visual mode here, it's worth noting, is literally just the ability to visually edit text in a sort of interactive way. So more basic than the visual mode that exists in Vim. So yeah, I did want to point that out because I realized that could be a bit of a terminology caveat. Now, the name VI comes from the abbreviated X command to enter into visual mode. The long form is visual here. So that's where VI comes from. It's just visual. So if you really wanted to expand things to their full names, Vim technically is not, well, it is VI improved, but that just means visual improved. It's the improved visual mode of EX. So there we have it. We have the line, the string of editors. We start with ed. We then go to EM, the editor for mortals. We then go to EN, which Bill Joy and Chuck Haley created, I believe, if I remember rightly. Then from that we have EX. Then we get VI as a mode of EX from which Stevie is cloned, and finally from which Vim is made. That's it. That's the long story of Vim. Hopefully that made sense. If you want to look into this in a bit more detail, I do encourage you go to the Wikipedia articles and read up, or search for interesting videos on the history of Vim. I think there are a couple on YouTube, but definitely there are several articles, or should be, online, not just Wikipedia. But yeah, hopefully that was clear enough. So yeah, the whole aim of this is that you don't have to go looking through all these other articles online. But yeah, I find that pretty interesting. That's a good history lesson. Anyway, I wish they taught that at school. So that's Vim done. What about Emacs? We're going to do the same thing. So let's go to Emacs. Here we go. And start over. We're going to go from the history bit. We're not going to read the intro. So, Emacs development, if I can scroll properly. Here we go. No, still not. There we go. Emacs development began during the 1970s at the MIT AI lab, whose PDP-6 and PDP-10 computers used the incompatible time-sharing system operating system, shortened to the ITS operating system. That featured a default line editor known as Tape Editor and Corrector, TECO. I imagine it's called that because it literally edited some tape. So, yeah. Now, having seen a teletype printer, we should not be surprised at that idea. But still, it always surprises me. Unlike most modern text editors, TECO used separate modes in which the user would either add text, edit existing text, or display the document. So this is very much like Ed. One could not place characters directly into a document by typing them into TECO, but would instead enter a character, I, in the TECO command language, telling it to switch to input mode. Enter the required characters, during which time the edited text was not displayed on the screen, and finally enter a character escape to switch the editor back to command mode. So this is very much like Ed, and yeah, they mention that at the end here. But I say that it's much more familiar to someone who's used Vim, because I is the sort of insert command, and then escape is the button you press to go back into the command mode or normal mode in Vim terms. So yeah, that's pretty cool. That's pretty cool. By the 1970s, Tico was already an old program, initially released in 1962. Richard Stallman visited the Stanford AI lab in 1976 and saw the lab's e-editor written by Fred Wright. He was impressed by the editor's intuitive WYSIWYG, which is what you see is what you get, behavior, which has since become the default behavior of most modern text editors. So literally just, if I open KWrite, what you see is what you get, this behavior. Although, you can see the whole file and sort of edit it accordingly, seeing the whole file. So Richard Stallman saw that in the E-editor written by Fred Wright. He returned to MIT, where Carl Michelson, a hacker at the AI lab, had added to Tico a combined display editing mode called Control-R that allowed the screen display to be updated each time the user entered a keystroke. It's worth thinking about that for a second. So when I'm in a text editor like this, KWrite, a modern text editor, just a normal one, if I go back, you can see my cursor go back. If I type J, you can see the J is typed. That is no different from what's being described here, although it's just described in a bit more of a technical sense, because whenever you press a keystroke in a modern text editor, the display is updated, it's re-rendered. That's exactly what happens. If I type E, the E is there now because it's re-rendered after I press the key. So it's just worth thinking about that. And you can begin to see how these text editors are programmed. The program is checking for a keystroke. If a keystroke is given, it re-renders the display. And there you have a text editor. What feels like you editing the text hands-on in this kind of way is really just you going to a specific point, pressing a keystroke, and the program re-displaying that whole state of the file. So it's, yeah, I don't know. I just think that's worth noting, because you begin to see text editors in a bit more of a technical way, and that's how they would have seen them to begin with. Anyway, here we go. Stallman re-implemented this mode to run efficiently and then added a macro feature to the Tico display editing mode that allowed the user to redefine any keystroke to run a Tico program. Already we have Emacs pretty much in terms of behavior. We have macros, keystrokes, and that's more or less it, sort of visual editing. And yeah, we're good to go. This already begins to look a lot like Emacs. E had another feature though that Tico lacked: random access editing. Tico was a page sequential editor that was designed for editing paper tape on the PDP-1 at a time when computer memory was generally small due to cost. And it was a feature of Tico that allowed editing on only one page at a time sequentially in the order of the pages in the file. Instead of adopting E's approach of structuring the file for page random access on disk, Stallman modified Tico to handle large buffers more efficiently and changed its file management method to read, edit, and write the entire file as a single buffer. Almost all modern text editors use this approach now. There we go. So that was a new thing that Stallman added, which was this idea of handling full file buffers. And I can't get my head around still that, this is something we take for granted. If I open KWrite here and type stuff, I'm editing the whole buffer of the file that I haven't written to the disk yet, but it's the whole buffer in memory. And that comes from this sort of idea. And there was a time where this did not exist. And that's pretty crazy to me. But anyway. Yeah, I probably can't comprehend it fully because I'm just so used to it being like that. But anyway, the new version of Tico quickly became popular at the AI lab and soon accumulated a large collection of custom macros whose names often ended in Max or Mac. No, in Mac or Max, which stood for macro. 2 years later, Guy Steele took on the project of unifying the diverse macros into a single set. Steele and Stallman's finished implementation included facilities for extending and documenting the new macro set. The resulting system was called Emacs, which stood for editing macros, or alternatively E with macros. Stallman picked the name Emacs because E was not in use as an abbreviation in ITS at the time. So he chose E just because it was available and was handy, it seemed. So that's pretty good. Cool. And the rest of it is just, yeah, there's not too much added here, I think. He just talks about, the article just talks about how Stallman made the project management of Emacs more uniform, so it's not just all over the place. But that's pretty much it in this section. So the main implementation, really, just to read this bit, I don't think is worth. You know what? I think it is. In the following years, programmers wrote a variety of Emacs-like editors for other computer systems. These included Einer. Einer is not Emacs, it's a recursive acronym, kind of like GNU, it seems. And Zwei. Zwei was Ein initially. Oh, it's Ein. Oh, it's just Ein, is it? I don't know. In German, it doesn't have the E at the end, I think. But anyway, I could be wrong. Yeah, Zwei was Ein initially. That's pretty funny. So, cool. So these two Emacs implementations were written for the Lisp machine by Mike McMahon and Daniel Weinreb. Weinreb, yeah. And Sign, which is Sign is not Ein, also, which was written by Owen Theodore Anderson. Cool, so we got a bunch of sort of initial implementations that sprung from this. Weinreb's Ein was the first Emacs written in Lisp. In 1978, Bernard Greenberg wrote Multics Emacs almost entirely in Multics Lisp at Honeywell's Cambridge Information Systems Lab. Is that in the UK? I think that's in the UK. No, North Carolina. Okay, never mind. Yeah, thought it was Cambridge. Anyway, Multics Emacs was later maintained by Richard Soley, who went on to develop the Nile Emacs-like editor for the NIL project, and by Barry Margolin. Many versions of Emacs, including GNU Emacs, would later adopt Lisp as an extension language. And that is the case today. GNU Emacs uses Lisp as the extension language. Now, James Gosling, who would later invent News and the Java programming language, wrote Gosling Emacs in 1981, the first Emacs-like editor to run on Unix. Gosling Emacs was written in C and used Mock Lisp, a language with Lisp-like syntax, as an extension language. Interesting. Early ads for Computer Corporation of America's CCA Emacs. Steve Zimmerman? I guess Steve Zimmerman must have been the main presenter, I guess. No? Maybe? Appeared in 1984. Interesting. Okay. Maybe, wait a minute. Corporation of America. I guess, my bad, sorry. Not a presenter. This must be just another spring off of a branch of Emacs, and this was the guy that made it. Yeah, anyway. But early ads for it appeared in 1984, must have been proprietary. Then in 1985, comparisons to GNU Emacs when it came out mentioned free versus $2,400. Right, I see. So there were proprietary versions of Emacs, and I think Gosling Emacs was an example of that as well. And then I think GNU Emacs, when it came out, mentioned the fact it's free. So that's pretty cool. Anyway, Richard Stallman began work on GNU Emacs in 1984 to produce a free software alternative to the proprietary Gosling Emacs. Yeah, cool. So Gosling Emacs was proprietary. GNU Emacs was initially based on Gosling Emacs, but Stallman's replacement of its mock Lisp interpreter with a true Lisp interpreter required that nearly all of its code be rewritten. Okay, so he basically rewrote the whole thing. Yeah, got you. I mean, I don't think he could have used the source of Gosling Emacs anyway because it was proprietary. And that must have been the reason. So, anyway, this became the first program released by the nascent GNU project. Okay, so, oh wow, so the first, yeah, okay, makes sense. The first GNU project program was Emacs. GNU Emacs is written in C and provides Emacs Lisp, also implemented in C as an extension language. Yeah, so that's really important about it. Emacs is basically a Lisp interpreter, and that makes it very powerful and very different to how Vim behaves. Like, the fact it can interpret Lisp was its core thing, right? But in Vim, it was never, that wasn't a core problem or thing with Vim. It just needed to edit text. But with Emacs, you can begin to see there's a lot more to it. But yeah, I won't read the rest. I think it's fairly straightforward. You can read it, of course, in your own time, but there's a lot of history there. Yeah, blimey. But it's being developed now. Like GNU Emacs is an active project now, but a lot of the other forks, or most of them, if not all of the other forks, are pretty much inactive now, if not dead, right? So yeah, that's worth mentioning. But yeah, that's it. We can see the history for Emacs is a lot more. It's a lot less, rather. It's a lot less distinct compared to the history of Vim. There's a lot less distinct stages going on, right? It's just you start with Tico, and then these guys just made it better, and then Richard Stallman made it better in loads of, I think to hand it to him, loads of niche and new ways at the time, and very effective ways, and therefore from that we get Emacs basically. So that's pretty cool. Again, I encourage you to look this up, like look at some cool videos on YouTube, look at other articles that might explain it better than this Wikipedia page seems to explain it. I know for sure there is a video on YouTube that's very good. I think it's the only video. If I go on Google, like YouTube Emacs history, there's one video in particular. Yeah, this one, the history of Emacs. This is the one. Yeah. Is it this one? I think it's this one.
In 19...
Yeah, that's the one. Yeah, this is definitely the one. These guys go through the history of Emacs in a bit more detail, I think. But yeah, I think this is the only video I managed to find on the history of Emacs, but there should be others, hopefully. I hope there's others. Cool. So, to recap, we looked at the history of Vim and the history of Emacs. And in doing so, I really, really, really hope you can now appreciate where they come from, the time that they came from, why Vim has modes, where the modes come from, why Emacs has the macros that it has, and why it being a kind of modeless editor is actually quite novel, or was quite novel at the time. I say modeless to mean there were no modes like ed or VI or Vim. Like when you type a letter in Emacs, you get a letter by default just being inputted like this. Bang, there's a J, right? That happens in Emacs, but in Vim, you have to first go into insert mode and then type J. If you type J in Vim, by default, like after just opening Vim, you actually will go down, you move the cursor down, right? I'll go into that a bit later, but there are no modes in Emacs, and that was quite a new thing at the time. Cool. So yeah, with that, I hope you enjoyed this little rabbit hole, or, several rabbit holes. And I also hope that you join me for the next video. Thank you very much.